Hi, I'm Joshua Finn from J&H Aerospace. Today we're going to build the Windlance. This is the largest boost glider currently on the market as of this filming, and we hope you enjoy it. So what I'm going to mention before we get started, later in the instructions you'll see instructions for balsa nose cone. Our production models are not going to include this, so the rest of this build video was actually filmed prior to our recording today. So disregard those instructions. They're part of your pylon assembly, and you'll see a shorter pylon in the video. This is the production model. So just be aware of that difference. We're going to go ahead and we're going to go through the complete inventory of your kit. So when you get your kit, you'll of course have your instruction, your cover sheet, and you're going to have all the documentation. In the documentation are patterns for all of the parts for this model, so if you break anything you can replicate it. So inside your kit you'll have parts for your fuselage core. You will have two of these. These are your wing leading edge halves. So it's basically the front half of your wing. You'll have your wing trailing edge halves. We'll have a sheet of 1/8 inch balsa, which is your canard, which comes in two pieces, and fuselage nose side plates. A piece of plywood, which is your fuselage sides. We have a sheet of 3/32 balsa, which contains your fin, your locking lugs for your fuselage pylon. This is your dihedral gauge over here. We're going to have a little piece of 1/16 balsa, which includes two pylon locking lug spacers. You'll only actually need to use one of those. We have a plastic nose cone. Empty everything out of here. So we're going to have a 9-inch long piece of Estes BT50 body tube. Have a piece of nose weight, which is your clay, the launch lug for 3/16 up to 1/4 inch launch rod, and you'll have a 36-inch streamer, and there we go, a 36-inch Kevlar shock cord. So those are all of your parts, and now I present to you the build video for the Windlance. Okay, so the next thing we're going to do is we're going to steal my wife's razor blade that's being used while this is going on. Let's see, can you see this? Yeah, more or less. Alright, so we're going to cut these wings out. These are the front half of the wing. Like so. And there we go. And then we're going to bring in the trailing edges. And our wings are going to fit together like, let me turn you down a little bit further. There we go. Wings are going to fit together like this, and like this. And this forms your traditional Aletta plan form, just a much larger one. So now what we're going to do is we're going to take CA we're going to join these together. I'm going to borrow some CA. And I'm going to get yelled at for borrowing some CA. And there we go. Ideally, you would do this over wax paper, but I forgot to go get some. And you'll repeat that for the other side. What I'm going to go ahead and show you is, just want to make sure that's all dry. Next we'll go ahead and we'll airfoil this out here in a second. Okay, now that we have some wax paper, you can cut in from this direction or what have you. I would recommend going from the root out, and that's because eventually you're going to be intersecting your wing here at an angle. If you come in this direction and try to cut across, you're going to dig into the grain because you're going like so. And as you know from our previous videos, typically we join the wings together and airfoil them together, but because with the Aletta you have the swept back trailing edge, that does not allow you to make straight cuts across. Now there's quite a bit of material that you need to remove here, and you can use your judgment as to how far you want to take this. This is a very, very large wing as boost gliders go. You're going to be shooting it up to very, very high altitude, so for most of you, you really don't need to do a whole lot, and you can still get very, very good performance out of this airplane. We are using a little bit thicker wood than comparable aircraft like the old Edmunds kits. I think they were 3/16 balsa. This is 1/4. So you do need to take some time to airfoil it out. The reason we went with 1/4 instead of 3/16 is simply that 1/4 gives you a better airfoil cross section. I think the 3/16 inch balsa for a wing court this wide is just too thin to really be capable of delivering maximum performance. And we do want this kit to be capable of that, so that if you want to extract the last bit of performance out, it's there and it's available to you. I'm trying to, there we go. I don't need to remove like 8,000th at a time. I want to go a little heavier. Alright, we'll come back online here after I have made a little more progress at this, because, like I said, lots of wood to remove here. Okay, so what we have done is from about here back, we have just a wedge shape going back. I have thinned this so it's about 3/32 of an inch thick at the trailing edge. You can go thinner. I don't think it's really necessary in this. Keeping it kind of thick like this does help to eliminate flutter at high speeds. So if you're wanting to ever fly this with like E-engines or something, it's kind of helpful there. I don't think you gain much additional from going down to like 1/20th thick, and I would definitely not go below 1/20th because your wood starts to become vulnerable for warping and whatnot, and once you get below 1/20th on the trailing edges here, you do not get measurable advantage from it. I mean, like 5 seconds, but the difference in the burns of your engine is going to be greater than that. Now we're going to move on to the leading edge, and I would say from about this notch, you could draw a line out here if you wanted to. I personally don't. I just kind of go by feel. You want to go ahead and start shaping this down. You can curl around the leading edge some. what we're going to do is we're just going to keep doing that. We'll come back when we're done. Okay, so where we are now is I have left the leading edge of the wing about 1/8 of an inch thick. We've feathered this in, so we stopped planing right here. I curved it around on the tips. Really, it's just a larger version of the Aletta, so when I come back, I'm going to crank some out of the lower surface of the wing, and you can go all the way like an inch back if you want to. Get fancy with it if you wish. Not a whole lot of advantage there. At this point, I would just go along here and give yourself a rounded edge, and the rest will sand out. Be back in a minute with some sandpaper. Okay, so what we're going to do here, please excuse my son in the background. He's getting ready to go outside and fly his own Aletta. Basically, you just want to smooth out the leading edge here. And then you'll come around, round things off a little bit. You can leave it sharp like with a stand foil. But I don't think there's a huge advantage to that with this style of aircraft. I guess that means more research is to be done. The problem is I don't think there's been enough research into airfoils for canards, so those of you who are our customers are welcome to send me your thoughts on that. Hi, Caleb. Say hi. Say hi to the camera. The camera's up there. Say hi. Okay. You've contributed enough to the build. And we're going to continue across the back here. Carve this nice and flat. Basically, from that line that we went right along like so back, I'm just carving it flat, or sanding it to maintain that flatness. Got a rough spot somewhere in my sandpaper. Let's write this one in. There we go. That's better. And then over the top, we just round it out a little. And we'll round off the trailing edge a little. And I guess also should sand the lower side a little bit, underside, yeah, bottom, something like that. I can't words tonight. What else is new? And there you have it. Nice airfoil cross section. I don't know how well you can see it there. And now just repeat that with the other side. I guess, yeah, go ahead and bevel this wing as well. You do need your dihedral. And you can actually check it just against part of your trailing edge for the other wing. There we go. Alright, we'll be back once the other wing is shaped out, and you can go from there. I forgot one item here. Now that we got this second wing joined, make sure that you set your other wing over here nearby, because if you don't, you could find yourself doing that. And that's how you end up with two left wings, or two right wings, or something of that nature. So, have your other wing nearby so that you remember not to turn yours upside down or something of that nature. Okay, be back in a minute. Alright, now we have two wings here. So, easy enough to, so we've already beveled them out. Let's see if I can center you up a little bit here. There we go. And there you go. So you see these come up pretty well. Next, let's try and find the razor blade. Here it is. We go over here to our rudder sheet. Vertical stab, not a rudder. Rudder is the part you steer with. It's part of the vertical stab. Oops. Oh well. This is our dihedral gauge. So again, we'll fit these together. We'll verify that, holding that up, that we get a good and a precise fit. Everything looks good. Make sure you line up your rudder or vertical stab alignment marks. And now all we have to do is bring in some CA to the task. And fit our wings back together. And one thing you'll notice is I'm holding this wing a little grabby right here. It's because this piece was curved a little bit. Pay attention to that. We try to control that as much as possible, but wood does have internal stresses and sometimes it will warp a little bit. In this case, a little more than I wanted it to. So, fortunately front and back are secure, so I'm going to come in here. I'm going to dribble a little more in here. Which doesn't hurt anyway, because you want this join to be good and strong. I mean, it's going to be going well over 100 miles an hour on the way up. And we'll dip some kicker onto it. And there you go. Go ahead and sand, get a little bit flat. And that's all that's required there. So, now you have a nice big wing. Next step. Bring out our parts for our fuselage. And this is some very, very thick wood here. Well, so is the wing for that matter. Occasionally you'll have a little bit of it that doesn't cut through quite all the way. And there you go. So to explain what we're doing here, this part of the fuselage is going to fit back over over the wing. It'll require a little bit of massaging into place. We'll deal with that in a few minutes. First we want to assemble the front of the fuselage into place. And we'll want to clean this apex out a little bit. And the fuselage should lock in real pretty like that. Be very thorough with this glue joint because this is a very critical juncture in the aircraft. Now, next thing we do is we've got these plywood side plates for the fuselage, and we can go ahead and put those on. So those are going to slot in. Not slot in, but they're going to fit in just like this. As you notice, we overlap back here. So, spread all of this with CA. Again, we line up on our canard slot there. Put this guy down and should be secure. And we just rinse and repeat on the other side. I will warn you, with that amount of CA put out, you're going to pick up some fumes from the curing process, which I'm experiencing right now, and it's ensuring I'll have a nice runny nose later. But the important thing is your fuselage is nice and straight. And I'm going to pause the camera for a second. Okay, now we'll continue. We have, over on this 1/8 inch balsa sheet, we have these side plates. These are for our nose, and they are, I shouldn't call them side plates. These are the locking keys for the pop pod. So we break out those little guys. And those simply line up on the front of the nose with everything else. Sorry, I'm out of frame here. So like so. And then we do the same thing over on the other side. And there we have it. And our ballast port is right there. Okay, next task is we will go ahead and take care of our canard here. Now, one thing that I will say while I'm doing this, if you sanded a nice airfoil into your wing like we did, you must airfoil the canard. If you don't, and the airplane gets into a really deep dive, it may not pull out. There is enough built-in incidence that at normal speeds that may not be an issue, but remember, this is being a rocket-powered model, you can get into some much more aggressive scenarios, and so you want to prepare the aircraft to be able to deal with that. So what I've done is I've broken out this this front piece for the canard, and I'm going to simply line that up on here and pull it in like so, and there you go. And now we'll just go around, we'll cut a fairly basic airfoil. Do not thin the edges down to less than 1/16 inch. Reason being, there's just too much risk of flutter kicking in if you do. As I cannot express enough, this is a very, very fast-moving aircraft. And so traditional balsa construction, lightweight construction, what have you, is generally anathema on an aircraft of this nature, just because of the perception that they flutter so easily, and it is true. And that's why we strive to supply the best wood we can in these kits. That's why you're paying a premium for a J&H Aerospace D-engine boost gliders, because this is a pretty aggressive airplane. And we'll smooth things over out here at the tips. It does actually behoove you to take a little bit of mass out of the tips, because that actually increases the speed at which flutter initiates. And here again, we've just introduced a little bit of camber so that we ensure stability, but we have not sanded down enough to make flutter a high risk due to the surfaces just being overly flexible. Now, if you're going for maximum performance on this airplane, you can go to a really nice airfoil on here. You can sand this thing down nice and thin, and then you can adhere tissue paper to the top and bottom of this canard using model airplane dope like butyrate or nitrate dope, and then it'll be more than stiff enough to handle all that. Actually, you've got enough budget for nose weight, you could even fiberglass this. You use like one of your PVA glues or something like that. No, water-based polyurethane. That's a popular solution for just lightly adhering fiberglass to surfaces like this. So all we're doing is we're trying to taper things down to give us a nice airfoil around the edges, give us mainly just to get the camber. We're not going for a super good airfoil, we're just going to get that camber so we can at least get the lift coefficient, even if the drag coefficient with it is a little higher than we'd like. Alright, so that is sanded out. Now all we have to do is look in here, and our canard slots in place perfectly. So, And we make sure that it sits square, and it does. One thing you notice is we didn't even really do a lot of sanding here, and I will just do this now to demonstrate that, hey, yes, you can sand it, you can round the nose off real pretty light, doing a number of things. We'll say a couple of things here. One of those is resist the urge to round off any part of your fuselage. It seems like a good idea. It's not. You reduce drag very insignificantly, but you trade a lot of structural stiffness. And you can actually layer this in back here, and that will make it lay down on the wing a little better, which is what we're about to do now. So we have kind of beveled this a little bit. We'll bevel a little more right here. Now, resist the urge to be that perfectionist and try to get the wing perfectly parallel this way to your canard. You want it to be slightly off from it, actually, and that will allow your airplane to turn a little, and that's what we've done. Now what you do want to do is make sure that this wing is very securely fastened. CA is heavy and we're using a lot of it. And that's okay. Because with this thing hundreds and hundreds of feet in the air, you're not going to really care about that part. Okay, we've changed views because our camera decided to die. And what we're going to do when I finish putting this tail plane in. Now you'll notice I have a little bit of a gap down here, and that's because I airfoiled this wing. So we leave you some material here in case you don't do that. So what I'm going to do is I'm going to come in here and I'm going to cut it down by this tab down by about half. Now, as you can see, we'll fit in real nice. One thing I will mention is by the time you get your kit, we will probably, because we're still in progress on this, you may find the slots are up here like so. So we get a flush mount back here. But for now, we're doing it like this. So what I'm doing is over my rudder mounting area, putting in lots of CA. Then what we're doing is making sure it's aligned mostly vertically. And there we go. That's all there is to that. Okay, so at this point your glider is finished. The next view you'll see from me is going to be using the regular camera. Okay, so the last thing we're going to do here is we're going to, well, last thing, you're right. We've got the glider done, so the next thing we're going to do is we're going to make our pylon. So we cut out this part, And then we'll go ahead and we'll snap out our pylon sides here. And you've got this little 1/16 sheet. Just take out one of these. Now what we're going to do is, if you'll notice, you can fit this component right there on the side of your pylon. So what we're going to do is put some CA on that. We're just going to set it on so it lines up. We only need to do that on one side. Then what you'll find is that your hooks will just overlay that perfectly. Now at this point we can come take our glider here. I'm going to fit this on here and make sure that there's a step down from here to here, and that means that we'll have a nice gap. So you want a little bit of play in that connection. And that means we can just come in here and we can glue the other hook in place. And try to get those parallel. I didn't. That's mostly okay. It does stress one more than the other, so you have to kind of watch that. Now you can see these latch in real nice. That's what you want. You want this to disengage very smoothly and slide back over your canard. And so at this point all you have to do is mount it onto your motor pod tube and you're good to go. Okay, we have our nose cone here. We're going to prep this for usage. These are Balsam Machining Service nose cones. So they come with this little insert. It has a hole right here, and that hole needs to go out. So we're going to go ahead and we're going to test fit that. Okay, everything looks good. So we're going to put some CA down in this receiving hole. And then all we have to do is press it all the way as far in as it goes. That's as far as it goes. Now you've got your eye hook, and so we can just hand screw this eye hook in place. Alright, eye hook is taken care of. Okay, so next we've got our body tube, got our pylon assembly, locking pylon. This body tube, you'll notice, is kind of short. This is shorter than what you'll have in your kit. Right now, as we're recording this video, we're kind of low on these, so by the time the kits are made available for purchase, that'll be all taken care of. I have already sanded a partial round in here off camera to receive the body tube. So what we're going to do is we're just going to glue this guy down. You can go mark the body tube for alignment as per the way that Estes and whatnot recommend you do and whatnot. The main thing is just as you're looking at this, if you focus in on it, you can kind of sight down the edge here and make sure it's parallel to a visible edge of the tube, and there you go. We want to fillet this in real good with CA. Yeah, it looks like mostly okay on this side. There we go. Alright, Take your launch slug. My standard practice is to mount it up on top. You can do whatever you want to. You can mount it down here in a corner or what have you. I just like to have the glider as far away from the rod as possible. This is a paper lug. We get lugs from different sources. If you have one of the glossy ones like the Estes lugs, you will want to sand your launch lug before attaching it, because the glossy, I don't know if they're waxed or however it is they're finished, but they do not adhere solidly if you don't sand them first. Alright, so we've got our pod assembly here. Next thing we want to do is set up our streamer. So we're almost finished with this aircraft. So we're going to bring this guy through. And there are a variety of knots you can tie. Just make sure that you get this streamer secure. And what I've done is I've threaded it through the streamer shock cord. Let's try that. I threaded it through the hole here on the pylon. And we'll come back through and we'll tie a second knot on this guy. And there we go. And cut off any excess. And then we'll come over here, and what I'm going to do is I'm going to go ahead and tie this off to the nose cone. There are 10 million different ways of doing this. This is my method. So you'll understand why I haven't tied in the shock or the streamer here in a second. Anyway, nose cone is secure. Got an adequate length here. And now what I'm going to do is I am going to take my streamer, twist it around a little bit here, and I'm actually going to tie the streamer onto the shock cord here. Or I'm going to attempt to. There we go. And now, at that point, you can let it slide on here, or do what I'm about to do, which is I'm going to also tie off the nose cone onto the streamer. Now, another alternative, if you wanted to, you could secure this with a snap swivel up here against the nose, or any number of things you want to do there. Main thing is now at this point, do not roll this up. You want to accordion fold it. It makes it work a little better. And so we just keep doing this all the way down. I think standard practice among some is to accordion fold these much tighter, but we're not going for streamer duration, we just want it to be visible. The main thing is don't roll up your shock cord, you're right, your streamer, or it will not unfurl properly, as I have experienced on several occasions. So, there we go. And then, what you'll do is you'll fit in your nose cone, you're right, your motor in, fit in plenty of recovery wadding, and then you can stick your streamer and shock cord assembly in place. And there we go. Alright, so at that point this assembly is taken care of. Please excuse Rooster in the background. And then we have a complete working aircraft. Now at this point, we've already verified we've got good sliding here, so good disengagement. You are going to need a stake in the ground for, actually let me back away here, I'll be right back. So the next thing that I would need to describe for you is how to set this aircraft up for launch. So the thing you have to understand with a traditional pod, this airplane's 3 feet long. So if you set it on a blast deflector, it's not even in contact. Well, it's in contact with maybe this much of the top of your rod, and that's not workable. So what you need to do is you need to rig up something like this system. So what I've got here, this is a full-length piece of brass tubing. You can use a carbon arrow shaft or what have you. And I have taped a 3/16 steel rod to the side of that. Another way of doing this would be to take like a 1-inch dowel and fasten it to your rod, or just drill a hole into the top of it, mount the rod into the top of that. That's another way I've seen of doing that. Is probably the cleanest way. And then you would sharpen off that dowel so you can stake it into the ground. What I'm doing is I'm going to take another steel rod, sink it down into the ground, because we have soft ground around here, so I can do it that way. And then I would just slide this over that. Now that'll give me a secure mounting, and also a great opportunity to poke holes in my ceiling. Now, very important thing is these steel rods like this will pick up oxidation. So you want to, this is Dow Corning 33 grease. You can use any type of well, silicone oil, not grease, but you can use any kind of oil or grease. You need to just lubricate up your launch rods so that it slides freely. I don't recommend WD-40 because it tends to wear off over time. But some sort of oily type lubricant will do a good job. And then at that point, now you've got this assembly, and you can slide your launch lug over this, and now it rides down very nicely. If there's any concern about if it's windy, it starts blowing the rocket up against here, what you want to do is turn this away so that this bottom of this rod is away from the aircraft. And again, if you sink it into the top of the dowel, that problem's taken care of. But the bottom line is now you've got a snag-free assembly for launching this. The glider does hold fairly securely onto the front of the onto the locking hooks, so you can fly this in fairly windy weather. I recommend that you face this. Let's say the wind's coming from that direction. You want the glider on that side, so if the wind blows it back, all it does is just hang up right here. And if you've got this properly lubricated up, even if it's pointing off the side, it won't snag, bind, what have you on the rod. You do want to watch for that, because I have a lot of problems with lugs binding on the rods, so I keep my launch rods oiled very regularly. I guess the main thing is make sure you use enough recovery wadding in here that you don't burn up the streamer. Paint this brightly. It's small and it's going to be coming in from very high altitudes. So, most model boost glider instructions say don't paint it. That's not true here. Paint this thing. This thing, be light in your coats of paint. I would like take either butyrate or nitrate dope the surfaces, and then paint them, or you can take varnish and take a paper towel and rub Minwax spar varnish on the entire aircraft, and that'll give you a nice finish as well. Give that a quick sanding, and then you just mist your color on. You don't want a heavy coat of paint, just enough paint that you get the nice color going. Apologies for the show you're getting in the background from our bird. But anyway, there will be a link down in the description for how to trim these for flight. You'll see me having a little bit of trouble trimming this one out. This is what you're seeing now. Actually, was filmed after that trimming video. When you get yours, you probably will not have that problem because we will have adjusted the incidence for the canard, so that's taken care of. But you should find this to be a very, very stable, easy to trim aircraft. If you have any questions, put them in the comment section below, and we'll see you later. Thank you for trying out this awesome D-engine rocket boost glider. Let us know how it flies for you. See you.